What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 videos. So if you are my 2021, 2022 classes watching this, I've posted the first 3 videos. Those were recorded last year, but with the packet stays the same, so they carried over. And this one I'm actually recording this year because if you looked at the 3 videos before this, we did everything in the packet except for question 7. If this is in the future, but I'm still using these videos, you could just kind of ignore all that. This is the 4th video doing the last problem just to finish up the packet. So I'm going to try to keep it relatively short. Again, it's honestly, it's something y'all need to see just so you know it's a possibility. Again, it's kind of fun for me. It's kind of math nerdy. You're not going to get tested on this because I could probably come up with a multiple choice question. I think there's actually a couple in Illuminate that bring up the possibility of imaginary roots, but which y'all see what I'm talking about in a second. But y'all see at the start problem, we're going to do the rational root theorem, but none of those numbers work for the rational root theorem. So we're going to have imaginary roots. Again, not going to test you on it, but we're going to go over it just so y'all can see it. And again, kind of math nerdy for me, kind of fun. Show y'all that even the imaginary roots still work. We'll see the graph so you can see that they actually don't cross the x-axis, and we're getting into graphing next week. So let's go ahead and jump in here to problem 7, the last problem in the packet. All right, so I was already down at the bottom because I'd finished doing the class. Let's go to 7. So again, previously in the packet, we had done a few cubic functions, factoring them, couple quartic x to the 4th, couple quintic x to the 5th. Question 7 says, let's consider a scenario where we're going to have imaginary roots. It's a little different than what we did on 6D. Again, if you watch that video, you already had it in your notes. On 6D, we had these last 2 roots wind up being -1 plus or minus I square root 7 over 2. So both of these last 2 roots, again, it's -1 plus this, -1 minus this. That's why it's the 2 roots. And then you would have had 2, 2, and 2 here. So these were imaginary. So we're still dealing with imaginary roots, but not in the form of this. Okay, it's not going to be from doing the quadratic formula. Because, as y'all are going to see in a second, I'm not going to have any rational roots to begin with, so I can't do the quadratic formula when this is x to the 4th. All right, so scrolling back down. Suppose we were asked to find the roots of x to the 4th minus x cubed plus 3x squared minus 4x minus 4. There are only 6 possible roots if we did the rational root theorem. Okay, again, you don't necessarily have to write this down. I didn't do it in class, but if you wanted to note it, that's P, that's Q. My factors of 4 are plus or minus 1, plus or minus 2, plus or minus 4. Factors of Q, there's no number, so we say it's 1, so it's plus or minus 1. So P over Q, P divided by Q would be those. Okay, 1, 2, and 4 divided by 1 is still going to be that. So it says we know the roots. So if we know the roots, these are the possible roots. If there was actually a root of this equation, we go back to the vocab we talked about at the beginning of the year. We said roots, zeros, solutions are all the same thing when we're talking about the polynomial. It's our x value we plug in that would make everything equal 0. And if it's a root, 0, or solution, it would be an x-intercept. So if one of these was a solution, or more than one of these were a solution, when we look at the graph should cross the x-axis at +1 or -1, +2 or -2 or +4, -4, okay? However, if we look at the graph, okay, I have typed in the R function over here. If we look at this graph, you know, I've drawn a couple. We're going to look at the graphs more next week. I've drawn a couple. They're supposed to look more like double parabolas, kind of like this. This kind of looks more like a single parabola. It's actually, if you can kind of tell from the shape, it's not a true parabola where it would be, you know, it would be a reflection over the axis of symmetry. If you try to draw, you know, a line up here, this left, my drawing's not straight, I realize that, but the left side would actually be slightly bigger than our right. But even not knowing the shape, if we come back, we know it's supposed to have 4 roots. We see it only crosses the x-axis twice. I promise if you zoom out, it doesn't, you know, turn back down here later like that, or, you know, does it over here. So only have 2 x-intercepts. We're supposed to have 4 roots, but I only see 2 x-intercepts. And even more so, like I was saying previously, now we can maybe zoom in. I have to hit it, it's behind my head. On the graph, it doesn't cross at -1 or -2 or -4 or +1, +2 or +4. We got 1.618 and -0.618. So we can see from the graph, none of those 6 roots, +1, -1, +2, -2, +4, -4, then none of them work. You know, if, again, looking at the graph, it's easier if we want to tie it back into how we've been doing it in class. You could try to do synthetic division with all 6 of these, okay? Again, you don't have to write what I'm about to write. I'm just writing so y'all can see. 1, -1, 3, -4, -4. We would start with +1. I'll work this one out just so y'all can see it. 1 times 1 is 1, 0. 0 times 1 is 0, 3 and 1 is 3, 3 times 1 is 3, -4 and 3 is -1, -1, -5. But none of those numbers work. None of them would give me a 0 right here for my remainder. Okay. So what does all this mean? None of these work. We saw there was 2 x-intercepts, but they're actually not going to wind up being rational solutions. If they were rational roots, they would be in here. So they're actually irrational solutions, which we'll come back to in a little bit. But that's only 2 solutions. There was only 2 places across the x-axis. So I was missing 2 roots because 2 of my roots are imaginary. When I have imaginary roots, they don't cross the x-axis. If y'all remember, when we talked about parabolas, when we did quadratics in Unit 1, if I have a parabola that does not cross the x-axis, that means both of the solutions would have been imaginary. So it doesn't cross the x-axis, has 2 imaginary solutions. This one, we're supposed to have 4 x-intercepts because it's x to the 4th, 4 solutions. We only had 2. That means I have 2 imaginary roots. Well, how am I supposed to figure out what those roots are? Again, if I just gave you this problem and told you to do it, you'd have no idea about going about how to find out. But the packet gives us our first root. Suppose we are told one of the roots to the function is 2i. Because roots come in pairs, think a minute about the quadratic formula. I already wrote it and erased it, but think about what I just wrote back up here for 6D. -1 plus or minus I square root 7 over 2. It's imaginary, comes in pairs, plus and minus. An additional root should be -2i. And again, this one you can write down if you want to. Again, you don't have to. But think all the way back to the beginning of the year when we did simplifying radicals with negative numbers. I showed a little bit at the end of the third video. If you want to break this up into the square root of -1 times the square root of 4, you can. But, we didn't do a ton of little numbers, but ultimately, what I tried to get y'all to remember was, I know if I have a negative inside the square root, I'm going to wind up getting an I somewhere. Okay, so I already know I'm going to have an I. So we get the I from the negative square root, so you can almost ignore this now and ask, what's the square root of 4? We know the square root of 4 is 2. But again, going back to the beginning of the year, let's think about the square root of 4. I'll just write it as positive 4. 4 has to break down to 2 equal parts. So I could do 2 times 2, but I could also do -2 times -2, which would give me positive 4. So that's why we got to stick the plus minus on. So here, plus or minus 2i, that's where I get here and here. So one of the roots is 2i, second one should be 2i. So now we know 2 of the roots, or what should be 2 of the roots. So let's take these values and use them. That means slash them and underline for synthetic division. I don't know why it kind of separated and made this extra point here, because we're going to go below. We're going to go over to the last page below where the factorization and the roots are, and do our synthetic division. It says, though the values may not be very clean, the process should work just as it did earlier. And y'all are going to see that that holds up. So I already wrote them out once. I'm going to write them out again so y'all remember, because it's on a previous page. We're using this polynomial. So to start my synthetic division, it's going to be 1, -1, 3, -4, -4. So let's scroll down, or I'm scrolling down. Y'all are flipping to the last page. We got my complete factorization, which again, we'll worry about that here shortly. Trying to move this, so I have a little bit of room. We're going to start our synthetic division. Again, we're using 1. Leave myself a lot of room because I'm going to have to squeeze in here. -1, 3, -4, -4. Draw my big L, do my box. I'm going to put 2i in my box. All right. As always, we said it works. Synthetic division works the same. We always bring down our first number. When I go to move it up and over, I multiply 1 times 2i. And everything I'm about to show y'all is stuff we have learned this year. It's a new application for it, but we've dealt with imaginary numbers. We're going to get some complex numbers, which y'all see in a second. We've dealt with those. So it's stuff we've already learned this year. Again, even though it's been a few months maybe since you've seen it. So it's nothing that we haven't learned. It's just a new application. Moving this over, we're multiplying it by 2i. Again, you can, I don't know if I would do it here because we're going to have a lot to write here in a second. I guess if you want to put times 2i here, just as a reminder, you can do that. 1 times 2i, anything times 1 is itself. So I'm going to put 2i right here. Now, this is where, again, I don't want to say tricky, but where, it's going to, and I mean, tougher is probably a better word than tricky, but again, stuff we've learned. We're just going to have to think back from it. I'm trying to combine -1 and 2i. I'm trying to combine a real number with an imaginary number. We know we cannot combine a real number and imaginary number. I can't say 2i minus 1 and get 1i. So I can't combine them, but I can write a number that we learned about that has a real part and an imaginary part. I want y'all to take a second, think and see if you can remember what that's called. It begins with a C. Hopefully y'all thought about it. So it has a real part and an imaginary part. It is called a complex number. So I'm going to have the real part, -1. That's positive 2i plus 2i. There's my complex number. The real part first and then the imaginary part. So what happens now is I want to move this complex number up here. but I still have to multiply it by 2i. So this is where it gets, again, I don't want to say tricky is not the right word. I guess you could say tougher is, but we know how to do the math. We're going to multiply 2i times this complex number. Okay. Multiply 2i times that complex number. We know what to do here, even though this is an imaginary number. I'm multiplying something outside by stuff that's inside in parentheses. We're going to use the distributive property. Okay, we're going to use the distributive property. 2i times -1 is -2i. 2i times 2i, 2 times 2 is 4. I times I is I squared. -2i plus 4i squared. You need to keep writing below when I want to do those, since I'm a little limited. I'm going to try to see if I can move this up so I can keep writing underneath. So you keep writing. You're just going to keep writing underneath there. You don't have to erase this and move it up. If it'll let me, I don't even know if it'll let me. May I just select? Oh, just take the I. I don't know if it's going to remove the whole thing or not. Maybe I do it outside and drag, maybe. There we go. That might work.
Yeah, some trash over there.
I honestly don't know. We'll move it up like that. I'm trying to finish this video, Miss Charlene. So if I do, I'll just take it with me. All right, so -2i plus 4i squared. Come back to this now that I got to move. So 4i squared, we see I squared. We learned this back in unit 1. Whenever I see I squared, I want to replace it with -1. We're going to do 4 times -1. So I'm going to get -2i minus 4. That's what's going to move underneath my 3. But again, I have to write it like a complex number. So when I write it under here, I'm going to flip my terms and get -4 minus 2i. Now see why I had to have a little space, because I had to have a little space up here, and I'm going to keep writing down here as well. All right, so again, let me see if I can move this. It's not capturing the window or the box for 2i. There we go. All right. So I'm just gonna have to slide it up and down, I guess. All right, now up here, 3 -4 minus 2i. So I have a real number, whole number by itself, and then the complex number. Obviously, I can't combine the complex number, but I have a real part and a real part here. It's almost easier if you picture like this is 3 plus 0i. So I'm combining 2 complex numbers, real part, imaginary part, imaginary part. Again, you don't have to write that. That might help some of y'all kind of visualize it a little bit. So I can combine 3 and -4, still get -1 again, and then the -2i is just going to come down. Move it up and over. But when I do, again, I got to multiply it by the 2i in the box. 2i times -1 minus 2i. It looks exactly the same over here. Only difference is now instead of plus 2i minus 2i. So I distribute 2i times -1 is -2i. 2i times -2i. We already know 2i times 2i is 4i squared. So now it's just going to be -4i squared. Let's drag it up now. Drag it up a little bit so we can see. We do the same thing with I squared. We got to replace it with -1. -4 times -1. It's going to be +4. So I've got -2i plus 4. Again, that's what's going to go up here. We can kind of see the -4 and -4 here. Again, you don't have to rewrite it. Obviously, put -1 over rational, 3 over irrational. Keep writing it, on down like you had it, but I'm just going to leave it up here so I don't have to keep moving it back and forth. So I got to move the complex number up here. Again, I'm going to flip. I'm going to put the real part 4 in front, minus 2i in the back. So I'm going to have 4 minus 2i underneath. We're going to keep going. Again, trying to combine this now. I got -4 and +4. Those will cancel out. Leave myself -2i. We did 3 minus 4 and got -1 here. Now -4 and +4 cancel out. Give me -2i. Again, I still want to move this up here. And when I do, I have to multiply it times 2i. So I'm going to have 2i times -2i. Again, we did it over here. 2i times -2i. I just don't have the -1 where I'm going to have the second term. So again, it's almost like you can ignore this. Don't scratch it out. Just showing you now how this looks the same. So 2i times -2i we know is -4i squared. Hopefully you know it turns into +4. Still want you to show me why though. Just to be safe, -4 times -1 is +4. So I just have +4 now. I don't even have a complex number. So +4 is what's going to go up here. And lo and behold, -4 and +4 give me 0. How about that? All right, so again, it's a little different from doing this in class. Hopefully you got enough room over here. We're going to have to do synthetic division a second time. I'm going to kind of squeeze it in. If you wrote this too big though and don't have room, you can do this second synthetic division on a sheet of paper and staple it in and turn it in with your packet. So what do I mean by second synthetic division? Well, 2i worked. I got a remainder of 0. So 2i is actually going to be our first root. We've now proven it. We said -2i should be our second root. So we're going to try to do synthetic division again with -2i. And we're not necessarily going to label these at this point. Remainder, constant, x to the first, x squared, x cubed. So you don't have to do all that, but the process is still the same. I'm going to take this complex number, -2i. So 1, -1 plus 2i, -1 minus 2i. Again, I'm going a little off the page. Hopefully y'all could fit it. -2i. And my box is going to go -2i. Now I'm going to try to do synthetic with this. First one always comes down, bring it up and over. 1 times 2i is -2i. This one's going to be a lot easier. Y'all might already be starting to see it. This one's going to be a lot easier. I did 1 times 2i and brought it up here, but now these didn't combine. I had to get a complex number. Here, I've already got the complex number on top, which happens to be +2i for the imaginary part. I got -2i, just like the 4s did over there. They're going to cancel out. And then the -1 is going to come down. Move it up and over. -1 times -2i. Negative times a negative is positive. So now I've got positive 2i. Now looking again. Again, pretty similar over here, except I had positive 2i, negative 2i on the bottom. Here I got negative 2i up top. Positive 2i, again, I didn't put a plus sign. You don't have to. We know when there's not a sign, we assume it's positive. Negative 2i, positive 2i cancel out, leaving me -1 again. It moves up and over. -1 times -2i is positive 2i. And now I've just got negative 2i and positive 2i. Cancel out and give me 0. So that one was a lot easier. So -2i worked as my second root. Positive 2i worked, -2i worked. Again, the only really complicated one was the first one. Second one worked out more easily. Now we can label these remainder, constant, x to the first, x squared. So I have 1x squared minus 1x to the first, so minus x, minus 1. Now I have this quadratic. So it's a similar problem to what we had on 6D. If we were going to try to factor this, the only thing I can multiply to get 1 is 1 and 1. So I'm going to put this up here in red, different color than I've been using. Don't work, so you don't have to write it. But if I were to try to factor this, only thing I can multiply to get 1 is 1 and 1. Okay. So both of these were positive. I would have x squared plus 2x plus 1. Not what I'm looking for down here. If I changed them both to negative, it would be x squared minus 2x plus 1. And since these are both 1, it doesn't necessarily matter, you know, if I'll use a different color, I'll use black. If I made this one positive, this one negative, or I flipped it, this one stayed negative, that one positive, I'd have x minus 1 times x plus 1. That would give me x squared minus 1. So there's no way for me to factor this quadratic. There's no way for me to factor this. So again, instead, what I'm going to have to do is use the quadratic formula. In class, since we've done the quadratic formula on 6D, I didn't make us work it out, but I told us ultimately what we're going to get if we did the quadratic formula would be 1 plus or minus the square root of 5 over 2. So this is now what I'm going to do. Hopefully you have this down. If not, you need to pause right now and make sure you do. Again, yours should have started out below where it says rational and irrational. Since I had to move it up, well, I'll tell you what. I'll move mine one more time, I suppose. Move it down. So it would have been down here. The other one could have been down here as well. So these are my last two roots, okay, right here. You know, we kind of I have to totally box it off like that. Let me do it like that. Okay. These are my last two roots. So the first thing I should have mentioned when we came down here before we even started this was a typo from the state when they posted the packet. There's only supposed to be 4 roots because it's x to the 4th. They have 5 spots though. So you can cross out this last one. Okay. These last 2 spots, kind of put a slash through them like we did on 6D. We'll write 1 plus or minus square root of 5 over 2 to the side. Those are my last 2 roots. We'll get the factorization here in a second. Let's go ahead and classify these though. 2i, negative 2i. They have the I, so obviously they're imaginary. 1 plus or minus square root of 5 over 2. They're not imaginary. There's no I. Square root of 5 should be the dead giveaway. I've told y'all, you know, with irrational numbers, we know pi is the most common one, but you know, we run into so many square roots in algebra 2. If I'm taking a square root that's not a perfect square, it's irrational. So I got the square root of 5, whether I'm adding it to 1 or subtracting it from 1 or dividing it by 2. They're both going to be irrational, but again, since there's no I, they're real. They're real, but they're irrational. And again, I'm not gonna whip the calculator out to show y'all, but if I did 1 plus square root of 5 divided by 2, I would get 1.618. If I did 1 minus square root of 5 divided by 2, I would get negative 0.618. Why does that sound familiar? I would get the 2 roots that I actually had. So if you did this in your calculator, this would be 1 plus the square root of 5 divided by 2. This would be 1 minus the square root of 5 divided by 2 to get this number. All right, so I don't know if there's a way to bring it back since I just changed screens. Maybe there's not. I thought it stayed when I changed screens. Well, hope you had all the work down. If not, you can rewind the video. I'll go ahead and rewrite these, I suppose. I thought the writing was going to stay when I moved it. I guess not. That's on me. So 2i, negative 2i, 1 plus or minus 5 over the square root of 2. These were imaginary. No, I had done the 1 circle. Let's do that. No, I can low enough. There we go. These were real and irrational. I will rewrite where I had x squared minus x minus 2 though, because I need that. We still got to get our factorization. This is the last thing. So to start with, 2i negative 2i, again, we can still apply what we've done previously with our zero product property, even with the imaginary numbers. So if I put x here, if I was going to plug this 2i here into x, so I had 2i, what would cancel out this positive 2i? Negative 2i. So x minus 2i is my first factor. Put an x here. If I plugged in negative 2i up here, what would cancel out negative 2i up there would be positive 2i. So that would be my second factor. Then my third factor, I couldn't factor this down anymore. That would be my third factor, x squared minus x minus 2. Okay. If you were to actually multiply all this together, again, y'all are going to have to take me at my word. If you multiplied x minus 2i times x plus 2i together, you would get x squared plus 4. And then you would multiply that by x squared minus x minus 2. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. You got positive 4 times x squared. Would be 4x squared. And then negative 2 times this x squared is negative 2x squared. Should be 3 though. Shouldn't it? It's supposed to be 3, right? Oh, yeah. Oh, because that's not 2, that's 1, because Coach Sharp is a dum-dum. My bad. All right, 1, 1. Now 1 here. So positive 4 times x squared would be 4x squared times negative 1. Negative 1x squared, 4x squared minus 1x squared would be 3x squared. Positive 4 times negative x would be negative 4x. 4 times negative 1 would be negative 4. So I would have gotten my original polynomial. Again, you don't have to write that. Obviously, you would have had stuff written there that went away, but I just wanted to show you the math because I'm a math. All right. So we've gotten through the packet. Okay. Gotten through the packet. I'll clear all that. I will stop sharing. So I'll say it in the videos last time, just in case you're watching the video. I need a reminder. In the packet, there are 16 parts. I guess I could be sharing the packet. Just go back through it real quick. Let me do that. In the packet, there are 16 parts that you are going to be responsible for. Come all the way back to the top. Okay. And again, this is for my 2021, 2022 classes. If I use these videos past this year, again, it'll seem like there's some discrepancies from my original videos, which I did last year, but we'll deal with that. Again, in the videos that I previously recorded last year for section 1, I do A, B, C, and D. You're only responsible, again, this is 2021, 2022 kids. I'm recording this on January 7th, 2022. You're only responsible for A, B, and C. You don't have to worry about D. Section 2. You got to use the quadratic formula. We are only doing 2A, but you got to do it. I think 4 of the 6 classes, we actually covered this in class before break. 2 of the 6. There's that week I was out a lot. I skipped over this. In the first notes video, I skip over this as well. I skip over all of section 2, but you are responsible for 2A. If you don't remember how, I will write this. So maybe if you're following along, you can write it next to it. If you don't remember how to do the quadratic formula, go into the solving quadratics assignment in Canvas and click on the quadratic formula video. If you don't remember how to do it. So that should help you do the quadratic formula for here. All right, we don't have to do B and C, which is the top of page 2. We've skipped down to section 3, which is when we talk about that we're going to have to do synthetic division to help us with these problems. Again, these problems with synthetic division, we're only doing it once, so you were told what to divide by. It's not where we had to do the rational root theorem yet. These problems, you're responsible for A, B, and C. Again, I believe most classes I did A, B, and C in class. If there's any classes where I skipped any of them and you need to go back and get them, 3A and 3C I do in the first notes video, but I do not do 3B. You are responsible for it. Again, if you forget how to do your synthetic division like this, I'll tell y'all what, maybe even some of y'all are actually watching this video. Maybe I'll give y'all a little reward if you're missing it. How about that? I'll at least this quadratic formula you can do on your own, but I'll at least remind y'all how to set this up because the synthetic division we did in the most of the packet was slightly different. You got 1, 3, -10, -24. RL. So now with the box, what we did in the packet, we looked at what we got for the rational root theorem. We're always going to have +1, -1. So we started with +1, tried to do it. If it worked, great. If not, moved on to -1. If not, moved on to, if we had 2, +2, so on, so on, so on. I don't have to do that here though, because I'm being told what to divide by. So if y'all remember what we put in a box, we use the constant from the divisor, the thing we're dividing by, but we use the opposite sign. So I'm actually going to do -4. So again, this is kind of your reward for getting through this video. If you made it this far, if you didn't have this problem, there's the setup. You still got to do the actual synthetic division on your own though. Okay. Again, get it down. If you need to pause it or go back and get it, do it, but I'm clearing and going on. Moving on down to section 4. So section 4, we start to talk about the rational root theorem. You have to do 4A. Again, that example is at the end of the first note video. You're not responsible for anything else after this. See if it'll highlight. You're not responsible for anything else after this, below that. It's basically talking about how to actually, solve this problem the way we're doing it. And we do that in 5A anyway. So you still have to fill this in. You don't have to answer any of these. I know a couple of the classes we did answer a few of these questions in class, so y'all have it down. That's fine. You don't have to raise it. You could just leave it. It's not gonna count for you, but it won't count against you. If you didn't get any of these questions in class or at the top of the next page, again, you don't have to worry about it. Define what the remainder theorem is. You don't have to worry about that. Again, dragging's not quite working, but when we've done the synthetic and we got the quadratic, if it's not factorable, we had to use the quadratic formula. We saw that on the problem we did in this video and the last problem of video 3. All right, section 5, 5A, 5B, 5C. Actually, now taking these, finding our possible rational roots, doing our synthetic division, factoring the quadratic, getting our complete factorization in our roots. So you're responsible for everything else in the rest of this packet. 5A, 5B, 5C, that's all in video 2. Section 6, we're looking at 4th degree and 5th degree quintic and quartic and quintic functions. 6A, 6B, 6C, 6D, that's all in video 3. So you need to make sure you have all that. And we just did 7 in this video. So that's everything you need. If you got any questions, let me know on your mind. Other than that, get your packets done, get them turned in for your grades, and I will see y'all in class.